Bio 2870 students, let's look at chapter 1.6. 1.6 continues this thought of homeostasis and focuses more attention on some of the details of negative feedback, and in particular how our body regulates temperature. Just like the thermostat regulated temperature in our home, how does our body regulate its temperature? And also introduces us to a concept that is a less common mechanism of positive feedback in regulating homeostasis. So we went through some of these slides already in lecture. You can go to the end of the last lecture on Echo 360. I'm not going to reiterate these points, but the textbook carries on this analogy from the thermostat in our homes to how our body thermoregulates. And so I'm going to skip ahead to this image that summarizes these concepts very well. So just like in a thermostat in our home, we have a receptor that is sensitive to stimulus, namely the thermometer, an integrating center or control center, namely the thermostat, which has a set point for room temperature, and an effector, like in the analogy, an air conditioner, or conversely could have been a heater. So too our body has these three components when it comes to maintaining homeostasis in regards to body temperature. So let's look at the upper portion of this image and see that similar analogy. If homeostasis is disturbed because there's an increase in body temperature above the set point of the control center, which is around 37.2 degrees Celsius, that is picked up by receptors in the body. There are temperature sensors, not thermometers, but neurons that are very sensitive to changes in body temperature. And so changes in body temperature trigger or activate these neurons that communicate that information to a control center. The control center in our body is not a thermostat, but it is found in the brain, primarily in the hypothalamus. And so the set point for our body temperature is around 37.2 degrees Celsius. Any fluctuation above that or below that, within a certain range, narrow range, will cause a hypothalamus to trigger a response, to send commands to effectors. In this case, the body temperature rising would cause effectors to counteract that stimulus and help decrease body temperature. So some of the effectors include things like blood vessels and sweat glands in the skin, causing an increased flow of blood to the skin, blood vessels dilating, activation of sweat glands to release perspiration. All of that causes the body to cool as the hottest water molecules leave through evaporative cooling, and the warm blood flow gets out to the periphery so that those water molecules can leave and the blood vessels can dilate and decrease body temperature. Conversely, if the stimulus is our body temperatures dropping because we walk out on a winter day, for example, and body temperature drops below the set point, say below 36.7, that information relayed to this control center again, the hypothalamus, which sends commands to effectors, again, blood vessels, sweat glands, and maybe even skeletal muscles, which respond with skeletal muscles with shivering, or blood vessels and sweat glands with decreased sweating and decreased blood flow, so vasoconstriction, such that you keep the bulk of blood flow near the core of the body so those vital organs are protected and kept warm, and we're not dissipating heat to the external world. Thereby, along with the shivering and decreased sweating and decreased flow to the periphery, an increase in core body temperature. Again, negating the stimulus that activated all of this, namely a decrease in body temperature. These are all examples of negative feedback because the response from the body, the response by the effectors, is going to negate or counteract whatever that original stimulus was, in this case a change in temperature. Now don't get the mindset that only body temperature is all that homeostasis includes. Homeostasis includes regulating the amount of water in your blood vessels, the amount of sugar or chemicals, electrolytes in your blood vessels, the amount of pressure on tendons. Your body is sensitive to changes in position and changes in posture. All of these things are constantly being regulated through homeostasis or homeostatic regulation, and the most common mechanism is negative feedback. Sometimes our body uses positive feedback, which, as the name tells you, it actually reinforces or further exaggerates the original stimulus. So, for example, in blood clotting, the laceration of a blood vessel may cause chemicals to be released from the blood and or from the cells lining the blood vessel that cause platelets to aggregate and to stick and start to clog up that wound. The platelets being activated actually stimulates them to release more chemicals that reinforce the clogging and clotting and activity of other platelets. And so the more platelets that come involved, they stimulate even more. And so you get this positive feedback loop. The end result is they clog or clot that laceration, and without the leaking of blood, there's no more release of these chemicals, and homeostasis is restored through a positive feedback mechanism. We also see this in the birthing process with the release of hormones like oxytocin.